Welcome to part 4 of the 7.3 notes. Again, this is trigonometric substitution. So if you see the integral of x over the square root of 3 minus 2x minus x squared dx, you might wonder how you can go about starting that integral. Again, u substitution doesn't really work, so one technique for handling these radicals is a trig substitution. Let's go ahead and give that a try. The only problem is that we have this 2x right here inside. If we just had 3 minus x squared, we could handle it. The a would be the square root of 3, and so you'd let x equal the square root of 3 sine theta. But here we've got this 2x right here that's bothering us. So what we can do is complete the square. Let's get this started over here. Complete the square. So we're completing the square for that polynomial that's inside the radical, for the 3 minus 2x minus x squared. And to complete the square, what we want to do is factor out the coefficient that's in front of the x squared from both of the variable terms. So we're going to factor out that -1 from both of the variable terms. And here I'm going to be switching around the order of the x squared and the x terms. So we have 3 minus open paren x squared plus 2x, and I left a little space to complete the square inside the parentheses. So you might remember, to complete the square, you take the coefficient in front of x, divide it by 2, and square it. So in this case, if you take that coefficient in front of x, divide it by 2, always by 2, and then you square it, here you'll get 1. So that's like the magic thing that you have to add to make that trinomial into a perfect square. Now, adding 1 inside the parentheses really subtracted 1 from the whole expression. So to balance that out, we have to add 1. That undoes the -1 that we just effectively did to change the expression, right? +1 inside the parentheses is like -1. Oh, it's telling me I'm going to be waking up in about 8.5 hours. Okay, this is my last video for the night. So the negative distributes to make this a -1, so we have to balance that out by doing a +1. That way we're not changing the expression. If you take a number and you subtract 1 and then you add 1 to it, you haven't changed the number. It looks weird because it looks like we're doing +1 and then another +1, which would be +2, but really this +1 in the parentheses is a -1. Okay, so that's completing the square. Let's go ahead and add the 1 to the 3 to give you 4. Then we put minus, and then we can factor that perfect square. It factors as x plus 1 quantity squared. Now, it may not seem like we've done very much, but when we go back over to the integral, I'll just continue it on down here. We have the integral of x over the square root of 4 minus x plus 1 squared dx. Fix that too. And this actually helps out because now what we can do is either do a u substitution, let u equal x plus 1, and then it'll turn into the square root of 4 minus u squared, which is something that we can handle using trig substitution, or just go directly into the trig substitution by letting x plus 1 equal, in this case, 2 sine theta. Sine theta. Kind of stumbled there. So let's let x plus 1 equal 2 sine theta. After we do that, the whole radical will collapse. Now when we take derivatives, the +1 is a constant that goes away, so we have dx equals 2 cosine theta d theta. Again, we'll put our little note here about theta being between -pi/2 and pi/2 to make sure that sine is 1 to 1. And we'll do our replacements. One small thing here is we have to replace x. So to replace x, we can take the original substitution here and subtract 1 from both sides, and we'll get x equals 2 sine theta minus 1. So x equals 2 sine theta minus 1. Now in the radical, we're going to have square root of 4 minus, and you know what, I'm going to go ahead and just square the 2 sine theta that we're going to replace the x plus 1 with. So I'm going to get 4 sine squared theta. Don't forget to replace the dx. This is a super common mistake. So replace the dx with the 2 cosine theta d theta that we came up with. And now we're going to collapse the radical. Collapse the radical. So we've got the square root of 4 minus 4 sine squared theta, and we can factor out a 4. Use a Pythagorean identity to write 1 minus sine squared theta as cosine squared theta. And then the square root of 4 cosine squared theta becomes 2 cosine theta. Alright, so the radical simplifies to just 2 cosine theta. So at this point we have a 2 cosine theta in the bottom, that's what the radical turned into, and then a 2 cosine theta from the dx, and those two things are going to cancel. Whoops. There we go. So we're left with the integral of 2 sine theta minus 1 d theta. And I guess that's pretty much the start of it. We're not too far away from finishing it, so let me just see if I can take a couple more steps to finish it off. So the integral of sine would be negative cosine. Integral of 1 will be theta. Remember that we're integrating with respect to theta. And now we have to get back from theta into x. So let's do that off to the side. So sine theta is going to be x plus 1 divided by 2. Go back to our original substitution and just divide by 2. And we can make a little triangle with angle theta in it. Opposite side will be x plus 1. Hypotenuse will be 2. The third side, by the Pythagorean theorem, will be the square root of 4 minus x plus 1 squared, which, if you wanted to write it, you can use the original radical, because that was the completed the square version of the original radical, right? So either one you want to use there is fine. Alright, coming back to the negative 2 cosine theta. So cosine theta here then is going to be the radical over 2. So this is going to be the radical over 2. I'm going to use the original version that we had, the square root of 3 minus 2x minus x squared over 2. And then the theta is going to be the inverse sine of x plus 1 over 2. So we had sine theta equals x plus 1 over 2, just inverse sine that. So we've got inverse sine of x plus 1 over 2 plus c. Kind of squeezed it in there. Now a couple of 2's cancel, and then you can squeeze your answer in. Negative the radical 3 minus 2x minus x squared minus inverse sine x plus 1 over 2 plus c, box, and done. So I guess we ended up doing more than just starting the integral. We actually finished the whole thing. But anyway. So that's the end of 7.3. Hope you enjoyed it, and see you next time. Thanks for watching.